And everything today is about absolute value. So to begin with, we're going to start talking about absolute value equations. Equations that have an absolute value symbol in them. And then towards the end of the lesson, we'll add some inequalities to the mix. We'll do less than, greater than, and all the different inequality symbols that we would typically see. Okay, so let's just think about, first of all, a real basic absolute value equation. The absolute value of x equals 8. So number one, we got to remember what absolute value means, right? And when we take the absolute value of something, we might understand what number I get, but really understanding what absolute value means is important. And so when we talk about, like, what is the definition of absolute value? Anybody remember what the definition of absolute value would be when we talk about absolute value? Jackson? Distance from zero, okay? And so when I ask you a question like this, the distance from zero is 8, right? So we're really asking ourselves, what numbers, what values of x are 8 units away from 0? And so there's really two things that would work here. We could go 8 to the right, or we could go 8 to the left. And so my answer here would be two different answers, positive or negative 8. And what I will tell you today is most of your answers we won't be able to put a plus or minus on, because it's going to be two totally different answers. Like it might be a positive 2 and a negative 3. They could both be positive, they could both be negative. You could have one positive and one negative. There's a lot of different combinations that you could have, but you'll have two different answers. But if it is the same number but just opposite signs, you can always write it as plus or minus 8. And we've seen that before, like especially when we solve like x squared equals something, we use plus or minus in some cases. So that's just kind of what we're talking about. Now we're going to see a lot of different expressions with this, and it's not just going to be x, unfortunately. If I were to put one up here like this, absolute value of 8x equals 24. What we're going to do in most of these scenarios is we're going to set the first equation equal to 24. We're just going to rewrite the exact same equation but get rid of the absolute value symbol. On the second one, we're going to say 8x equals negative 24. It's kind of the same premise that we talked about here. What numbers can I put into this absolute value that makes it equal 8? Well, if I covered up this 8x, I could take the absolute value of 24, which would give me 24. I could take the absolute value of negative 24, which would give me 24. So I'm just replacing the two numbers that would make that work. So here we're going to divide by 8, which gives me 3. And then divide by 8 again, and that would give me negative 3. And once again, we could write this as plus or minus 3, but we won't see that very often. Very seldom will the two answers be the same number with opposite signs. Because these are equations today, we can check every single one of these answers. I can take 3, I can plug it back in. 8 times 3 is 24. When I take the absolute value of something, my answer is always assumed to be positive. Same thing if I put in a negative. When I take the absolute value of negative 24, it becomes positive 24. Okay, so those two are pretty straightforward, but just kind of getting into remembering what absolute value was and how we're going to go through the method of solving these. Now we're going to get into some that are going to be a little bit more difficult. Absolute value of 3x plus 2 equals 1. Okay, and the one thing you always want to remember with absolute value is there's always going to be two equations that you're going to solve. So the very first thing that we should always do is we should write out the two separate equations. Okay? And so the first one, we're going to write 3x plus 2 equals 1. The second one, we're going to say 3x plus 2 equals negative 1. We don't do anything with the 3x plus 2. I see a lot of times people wanting to change the sign on like the 3x plus 2. Nothing happens with what's on the inside of the absolute value. The only thing that changes sign is the number that's on the other side of the equal sign. So the first one is 1, the second one is -1. And then it's just two two-step equations. I'm going to subtract 2. I'm going to divide by 3. And you're going to get some fraction answers today. Okay, don't freak out if you do, it's okay. That's going to happen. The work here is essentially the same thing. And as you see here, we get 2 different answers. They are both negative as well, and it's okay to have 2 negative answers. Sometimes they'll be both positive as well. Hey, and if you ever have any doubt, do you have to check it? Is the question I get all the time. No, but I talk about checking it because especially like on test on Friday, let's say, my question would be, why wouldn't we check it, right? If I wanted to verify that these numbers really work, you could simply plug that back in. You don't have to show me the work, but by plugging it back in, you can verify that they work, and then you know you got the right answers. You shouldn't have to wonder, did I get that one right or not? You can check it before I even get a hold of it and grade it, right? And so you'll know you got the question right. And so that's always the good thing about an equation, is you can always check it and verify you got the right answer. Okay, one thing I want to talk about real quick here. If I see absolute value equals a negative, okay? If I think about this and I say, what number can I plug in for x that would make this equal a -2? Well, what happens when I take the absolute value of any number? What's it always do to that number? Makes it positive, right? So no matter what number I put in here, like even if I put in 2, what would the absolute value of 2 be? 2, right? What happens if I put a -2 in here? It'd be 2, right? So there is no number that I can put into here that's going to make this equal a -2. So immediately, this is a no solution. Okay, and the reason I bring that up is because this one's pretty easy to recognize, right? Because it's equal to a negative immediately. But at any point in time, if you have the absolute value of some expression, whatever that is, equal to a negative, then it'll always be no solution. Okay, I don't care what's inside of here. If the absolute value is by itself and it's equal to a negative number, it will always be no solution. Okay, it doesn't matter what's on the inside. And I'm gonna give you some examples here where, as we start solving through, if I get the absolute value by itself and it's equal to a negative, then I can stop right there. I don't have to keep going. Okay, absolute value of 2x minus 1 minus 5 equals -3. Now, this one, I kind of throw you a little bit of a curveball here, because a lot of times people will see the negative over here and they'll be like, oh, that's no solution, right? That's only if we have absolute value is all by itself equal to a negative. We still have this -5 right here. And so if I have something on the outside of the absolute value, I need to get rid of that or move it. And so in this case, my first step would be to add 5. And when I do that, it gives me a +2. And now we're okay, because now it equals a positive number, okay? So that's the other thing to watch out for, is not necessarily just looking for a negative on the other side. Make sure the absolute value is by itself first. That's our first goal. Okay, once we get to this point, now I can do my 2 equations. 2x minus 1 equals 2. 2x minus 1 equals -2. We're going to add 1. We're going to divide by 2. Add 1. Divide by 2. Okay, and almost always we're going to get a negative number, okay? Or, I mean, two answers, not a negative number, but almost always we're gonna get two answers. There is an exception to the rule, and I'll show you what that is here in just a second. No solution is a possibility, but majority of the time, we're gonna get two solutions when we do this. Okay, in this case, we got one negative and we got one positive. So the two answers can be a lot of different possibilities. Okay. This one here is very, very similar. Once again, if we have something on the outside of the absolute value, we got to get rid of that, whatever that is. So in this case, we're going to subtract 5 as our first step. So that would give us 3x plus 2 in the absolute value equals -4. And here's where you just got to watch yourself as I go through. You got to be aware of absolute values by itself. Absolute value is equal to a negative. And I'm done. This is it. I can stop right here because I have absolute value of something equal to a negative. And I'm done. What happens here is some people don't recognize this, okay? And then what they'll do is they'll do 3x plus 2 equals -4, 3x plus 2 equals +4. They keep trying to go. And it looks like you get two answers. But if I were to check it, those two answers aren't going to work, okay? And so if you were to continue on this problem and you tried to check those problems, it's not going to work, okay? But much easier way of doing it is just identify it and know that when I see absolute value equal to a negative, I'm stopping right there. I can't go any further than that. Okay, let's do one more. This one has a lot of stuff going on in it. Okay, some different things to talk about here. I've given you a couple where we had something at the end, a plus or a minus after the absolute value. Here we have a 7 minus out in front. Okay, if this was parentheses, then we could distribute. Okay, but absolute value and parentheses are not the same thing. They're completely different. And what I'm going to tell you right now is when our sign is absolute value, you cannot distribute through the absolute value. Okay, it's a symbol. It's its own symbol, and you can't distribute through it. It doesn't work the same way as parentheses. And so a lot of people want to take this minus sign and try to distribute it, but you can't. You will get a different answer, and it won't be the right answer. Okay, and so just keep that in mind. Our first goal is to get rid of whatever is on the outside of the absolute value. And it might be a little bit tricky here, but what I like to think about is if I were to solve an equation like this, like typically my goal would be to get x by itself if I was solving an equation. Here, our first goal is to get the absolute value by itself. So if I gave you an equation like this, what would be our first step? Subtract 7, yeah. And so we're going to do the same thing here. We're going to subtract 7. Now, the minus sign in front of the absolute value is still going to be there. And if you wanted to, you could treat this as like a -1. There is no coefficient in front of the absolute value, but if you wanted to put a number there, it would be like if there's nothing in front of x, we know there's always assumed to be a 1 in front of there. We don't have to put a number there, but just so it kind of helps you that I got to get rid of that negative, so I'm going to divide by a negative. And in this case, it would be like dividing by -1. That gets the absolute value by itself. That's our first goal, is to always get the absolute value by itself. Okay, and then at this point, once we get the absolute value by itself, we want to make sure it's equal to a positive, which it is. Okay, so because it's equal to a positive, now we can do our two equations. If it was equal to a negative, we would stop right here and we would be done. So now we're going to go 2x minus 1 equals 1. 2x minus 1 equals negative 1. And now we can solve our 2 out. Add 1, divide by 2. Over here, we add 1, divide by 2. So our two answers are pretty straightforward, 0 and 1. Okay, because my answers are pretty straightforward here, I know sometimes like when we get decimal or fraction answers, we're like, oh, that's going to be really hard to check. Maybe a little bit harder than most, but two numbers like this would be really easy to check. And just to show you how the check would work real quick, if you wanted to do it, you wouldn't have to show me the work, and really, you can probably do it in your head pretty quickly. Let's start with 1. 2 times 1 is 2. 2 minus 1 is 1. Absolute value of 1, still 1. 7 minus 1 becomes 6. Works, okay? If I tried 0, 2 times 0, 0. 0 minus 1 is negative 1, but when I take the absolute value of negative 1, it becomes 1. And then once again, 7 minus 1 is 6, okay? Both of them work, okay? And this one is pretty easy to do in our heads, and we're just kind of doing some mental math. Make sure that when you check it, you're doing order of operations, so you're going to do what's on the inside first of the absolute value, you apply the absolute value, and then you simplify everything. And like I said, if this was like a half, it might be a little bit harder to check, but it still wouldn't be too bad. Okay, so just something to keep in mind, okay? Especially as you're taking the test later this week, that you can always check these, you can always verify if the answer works or not, and if not, then you can go back and figure out what did I make my mistake at, as long as you checked it correctly, okay? All right, so those are all absolute value equations, okay? Pretty straightforward. Most of the time we're going to have two answers in there. I told you the one exception. If I gave you one like this, most of the time we'll have two answers, right? This would be the one time that you would not have two answers. And the reason why is because if I were to subtract 8 from both sides to begin with, I get the absolute value of 3x minus 1 equals 0, okay? But 0 doesn't have an opposite. It's the only number that doesn't have an opposite, right? If I had 2, I could set it equal to negative 2. But I don't have a positive 0 and a negative 0. So the only equation I would have to set up here is 3x minus 1 equals 0. So that's the only time you don't have to do two equations. And then you won't have two answers, okay? And then I would just add 1, divide by 3, and I get x equals 1/3. Okay, the other thing I'm going to run by you here, these are going to be very, very similar, except there's a couple of different rules to them. First of all, what's different about it is we're going to have one of our inequality symbols, less than, greater than, less than or equal to, greater than or equal to. And it's going to look very similar to the beginning of what we did. Except when we write out the two inequalities, we have to decide, is it going to be an and statement or is it going to be an or statement? So let's look at an example of some different ones here. Absolute value of x is less than or equal to 2. The way I always remember this, if I have a less than symbol, and this rule only works for absolute value, but it's a pretty quick and easy way to remember it, is I remember this as less than. If it's a less than symbol, I will use in between, okay? And that goes for either less than or equal to or just a less than symbol. The equal to doesn't really matter, okay? But if it's one of the less than symbols, we're going to always use and, And there's a big difference between and or, and we're going to talk about that here in just a second. So it is a big deal whether we use the and versus the or, and it's not going to tell us what it is. We have to know which symbol and which word we're going to use. So what's going to happen here? First of all, the first inequality, just like we did with equations, we're going to rewrite it just like it is without the absolute value. X is less than or equal to 2. Pretty straightforward. Then we're going to put the word and in here. We're going to change this to a -2, just like we did with equations. But when I change this to a -2, it would be the same idea as like multiplying or dividing by a negative. And whenever we solve inequalities and we multiply or divide by a negative, what do we have to do with our sign? It's got to flip, okay? So when I write my second inequality out here, the sign will flip to be greater than or equal to. So those are my two answers. Now, we talked about some inequality problems earlier on, and a couple different ways that we could write it out. Okay, we wrote it in its answer form like we have here. We're going to write it in interval notation form, and usually we're going to graph it as well. So if I were to graph this, make sure you place the numbers in the right spot on the number line. -2 is further to the left, so I'm starting over here, and it's going to be greater than or equal to -2. So what we have to remember here is when we have a greater than or equal to sign, it's going to be a bracket opening to the right, because it's greater than, it's going right. X is less than or equal to is going to be a bracket opening to the left. And we're going to shade everything in between. So that's what my graph would look like. We're not going to use closed circle and open circle anymore. We're going to use either brackets or we're going to use parentheses. If we were to write our answer in interval notation, it would look like that. I like to graph it first, put everything on the number line, and then coming up with our interval notation is pretty easy. We're going to start with a bracket at -2. We're going to shade it all the way over and put a bracket at +2. So then writing the interval notation should be pretty easy off of your graph, as long as your graph is right. Hey, and what this really means here, okay, and we talked about checking this. Any number from -2 to +2, including both of those numbers, will work, okay? So if I really wanted to check this, I could take anything in that range, or in that domain, and plug it in, okay? So for instance, I love 0 because 0 is a piece of cake, right? 0 falls in that shaded area. If I put in 0 up here, absolute value of 0, still 0, is 0 less than or equal to 2? It is, okay? If I plugged in a number like -3, for instance, which is not in the shaded region, the absolute value of -3 is 3. 3 is not less than or equal to 2. And it shouldn't work because it's not in the shaded area, right? And so any number that's in that shaded area should work. -2, -1, 0, 1, 2. You could do fractions and decimals, which we probably wouldn't typically check those. You get to check by using any number that's in that shaded area. Okay, the other one that we're going to talk about is what happens if we have a greater than symbol. And the word that I use here, or the way that I remember it, is I spell it a little bit different. I think of it as great or. Instead of greater, great or just kind of reminds greater is or. So I kind of combine those two together. If this is greater than or equal to, then it's going to be an or statement. When I write my two inequalities out here, I'm going to say x is greater than 4, or x, and because we're changing this to a -4, it would be less than. Okay, I'll do one with you here that we will solve and have a little bit more work involved, but I just wanted to show you some basic ones here to start with. So negative 4 is going to be down here. Positive 4 is going to be up here. X is less than negative 4. So first of all, it's going to be a parenthesis at negative 4, and it's going to go shaded to the left. And then we have a little break in there. And we're going to start over again at 4, and it's going to shade to the right. Hey, and what you might remember is if my statement is and, the two should meet in the middle. They're going to connect. And that's what's happening on the one here on the left. They're meeting in the middle. This one and this one are coming together. Here, this one is going to the left, the other one's going to the right, and they're never going to meet one another. Okay? They're going opposite directions. So ors will typically go away or opposite one another. Or and opposite, O and O is a good way to remember that. When we write this answer in interval notation, because they're going to ask us today to write the answer in interval notation, which we've done before, we're going to say, how far left is this graph going to go? Negative infinity. Good. So we're going to go negative infinity all the way up to negative 4 with a parenthesis. And then since there's that gap there in the middle, we put this little U symbol in between to kind of link them together. And then we're going to start over again at 4. And we'll go 4 to infinity. So here, there's a ton of numbers that would work. Anything less than negative 4 will work. Anything greater than positive 4 would work. I could plug in a number like negative 5. Absolute value of negative 5 is 5. 5 is greater than 4. I could plug in a number like 7. Absolute value of 7 is still 7. 7 is greater than 4. But if I put in a number like 0 that's not in the shaded region, absolute value of 0 is 0. 0 is not greater than 4, so it should not be shaded, which it's not. Okay? So you could kind of check any number that you wanted to. Is it in the shaded region or not? If it's in the shaded region, it better work. And if it's not, then it should not work. Okay, so let's look at an example that is kind of like what we did at the beginning. Those, I just put X's inside the absolute value just to kind of show you the difference between and or. So the first thing we want to decide is what kind of statement will we have here? And or an or? And, okay? My symbol is less than, so we think less than and. So I'm going to write and here to start with. Because the absolute value is by itself, x plus 8 is less than 9. The second one, x plus 8 is greater than negative 9. Don't forget to flip the sign. Pretty common mistake. Because this is negative, it's like multiplying or dividing by a negative, and that sign must flip. Now we can solve both of these out if we have to. That's the only thing we didn't do on the last couple. Okay, and I kind of show you this one for a couple of reasons. Here's what happens sometimes when people graph this. Is the way they have this written out. Some people will do this. They'll put 1 here, and they'll put negative 17 here. Why is that wrong? Yeah, they got it. This has to be to the left, right? But people will do that because, oh, my equation's on the right, so then I'll just put my number on the right, right? They just kind of put it in the same spot as where the equation is. But you got to think about where it should fall on the number line. So this would be the negative 17, and this would be the 1. So you got to put numbers in the right spot. And then we're going to coincide it with the kind of graph that we want. So I'm going to start at negative 17. It's greater than, so it's going to be a parenthesis at negative 17. And at 1, it's going to be a parenthesis. Negative 17 is going to the right, 1 is going to the left, so it would be everything shaded in between. Ands should meet in the middle. Okay, they should connect. You should have endings. And there are exceptions to the rule. I'll show you that here in just a second. But when I write my interval notation here, I would simply just say negative 17 to 1. So you also got to watch out for your, do I want parentheses or do I want brackets? This does not have the equal sign underneath, so we just use parentheses. If I had equal sign underneath, then it would be brackets. With these, it's going to be the same symbol on both ends. It's either going to be both parentheses or both brackets, because we're essentially using the same symbol that I started with, right? And that symbol has or doesn't have an equal sign underneath it. So that's why, when we did it earlier in the semester, we could have like one bracket and one parenthesis. We won't have that here. It'll be either both brackets or both parentheses. There's no combo where you'd have one of each. Okay. Last thing to talk about here. I kind of always show you some special situations. Just these are some things that could pop up or we could see. We won't see them very often, but in case we do see them, we have to be ready for them. If I said the absolute value of x is less than negative 3. I mean, truly, you could do this the same way as what we did with equations, right? If I said, what number can I plug in for x that would make this less than negative 3? No matter what number I plug in here. Let's say I plug in 0. Absolute value 0 is still 0. Is 0 less than negative 3? No. If I plug in like a 1, absolute value of 1 is 1. Every time I take the absolute value of something, I'm always going to get a positive number, no matter what number I plug in here, right? So you just got to understand what absolute value is trying to tell you. So every single thing I take the absolute value of, I'm going to get a positive. And no positive is going to be less than negative 3. This is not a possibility. So that's the same thing for absolute value, okay, as in with inequalities. Now, as far as graphing this, if I say there's no solution, how do I shade on a graph? Yeah, it's just blank. It's just a blank graph. There's no numbers on that graph that make this work, okay? Which means there's also no interval notation either. And so it's just a no solution, okay? So kind of weird, kind of different, but it still works the same way as an equation would work. The other one would be, what if I had something like this? If I did my two inequalities here, my first one would be absolute value of x is greater than negative 5, or I could flip it and make it less than positive 5. Now here's where sometimes we get caught up on some things. Negative 5 is going to be a parenthesis, and it's going to be shaded to the right. Positive 5 is also going to be a parenthesis, but it's going to be shaded to the left. And what we said just a few minutes ago was or should go opposite, and these do go opposite. This one's going left, this one's going right, but not only are they going opposite, they are overlapping one another as well, okay? And so because they are overlapping one another here, what numbers would not be shaded here? What's that? Nothing. Everything is, right? So what would we say is our solution here? All real numbers, yeah. And so this is what our graph would look like. And then my interval notation would just be negative infinity to infinity, all real numbers. Okay. So those would be a couple of special cases that you could have. And another special cases is sometimes you could have where they're both going the same direction, but that won't happen very often with an absolute value symbol. Okay. Assignment for today. going every 5. 5 through 30 are equations, like the first half of the problems are equations, and then starting at 35, you get into some of your inequalities. And on the inequalities, you're going to have less than, you're going to have greater than, and they're going to ask you to solve it, they're going to ask you to graph it, and then you're going to have to write your answer in interval notation as well. Okay, so you're going to do all 3 kind of like we did on those last couple.